Hello, welcome to Tuesday. Hey, what do you think of the old Mr. Frazier from the future? When looking at him, I'm thinking, wow, he's still got his good looks and all his, muscles and everything. That's quite amazing. We're looking at, I appreciate Mr. Frazier from the future coming, but you know what? He couldn't teach that whole lesson about area of a circle. There's so much in it, we divided it up into 2 lessons. And so yesterday on Monday, he taught part 1, and now today, I've decided to teach part 2 and give Mr. Frazier from the future a break, okay? So here's what we're doing. First off, let's review a little bit about all these formulas we've learned. Okay, so, and the things about a circle that are really important to know. In a circle, a circle is all the points that are the same distance from the center. That's called the center. All right, the diameter would be from one point on the circle through the center to another point on the circle, and that's called the diameter. The radius is from the center to the circle. So radius is half the diameter. The diameter is twice the radius distance. We learned that. Circumference is the distance around the circle, and of course that uses a capital C, remember, when you designate circumference. Now here's some of the formulas we've been learning in 6th grade in geometry, all right? These, if you don't have them written down in your notes so you can learn these and make sure you have these down in your head, okay? Write them down and practice them like drill cards, all right? Make your own drill cards about these. The perimeter of a rectangle, ready, begin. Perimeter equals 2 times the length plus 2 times the width. What if you're talking about a square? And don't look at me when I say that word, right? The perimeter is 4 times S. 4 times S. I know Mr. Frazier in the future said he didn't care about it being called a square anymore, but I do. I'm not the Mr. Frazier in the future, okay? All right. How about the area of a rectangle? Well, the area of a rectangle is ready to begin. Length times width, always in square units. What if you're talking about a square? All right, don't look at me. The area of a square is one of the sides times itself, so we call that S squared. Area of a square is S squared. How about the area of a parallelogram? Now, I know a rectangle is a parallelogram. But let's say a tilted rectangle. It doesn't have square corners, all right? Well, area equals what? Base times height. We learned that last week. How about the area of a triangle? Well, I told you every triangle is half a parallelogram. So let's say the formula for area of a triangle. Begin. Area equals 1/2 base times height. Okay, how about the circumference of a circle? The distance around the outside of the circle. Well, we learned a special value called pi. And we use in 6th grade 3.14 or 22/7, whichever is easier to use. So let's say the formula for the circumference of a circle. Ready, begin. Circumference equals pi times diameter. Pi times diameter. How about the area of a circle? And that's where we stopped yesterday. The area of a circle is, well, I know old Mr. Frazier was really, really adamant that, pi are square. And I don't really know that. Most of the ones I've seen are not square, but I'm not going to, argue with him. But he's been saying pi are square ever since he's been in the future. So pi are square. What is the area of a circle's formula? Begin. Area equals pi r squared, right? Pi r squared. Now that means the radius times itself, all right? Hey, I got a question for you. Let's suppose you go to a nice pizza restaurant, all right? There are some great ones. Grant knows about one, right? Hey, how about this? We know that when it comes to deals, we want to get the best deal possible on our pizza because pizza is one of the 4 major food groups. You know that, right? All right, so let's suppose they have in the restaurant a 12-inch pizza, and you can buy it for $10. Good deal. And I'm talking about 12 inches diameter. And here's a 24-inch pizza. And a 24-inch pizza, it has a diameter of 24 inches, and it's $22. Oh, wait a second. That doesn't sound like a good deal to me. They doubled the diameter, and they more than doubled the price. I would think a 12-inch pizza to $10 or 24-inch pizza would be $20. And this one's $22. I think that's the better deal. Well, until you do this, and this is the interesting thing about area. Okay, so I'm going to get the area of the 12-inch pizza. Area equals pi r squared. Area equals 3.14 times the radius squared. Now, if that's a 12-inch diameter, the radius from the center over here to the edge is 6 inches, all right? 3.14 times 6 squared is 3.14 times 36. I worked it out. I got 113.04 square inches of pizza right here, okay? How about the 24-inch pizza? All right, what's the radius of a 24-inch pizza? Well, it's half of 24. That's 12, right? So area equals pi r squared. Area equals 3.14 times 12 square, radius squared, not the diameter squared, the radius squared. 3.14 times 144, because 12 times 12 is 144. I worked that out over here. I got 452.16 square inches of pizza. Now I thought, wow, that's a pretty big number, 452.16 compared to the 113.04. All right, this is all before I ordered the pizza, right? The waitress is going, okay, come on, let's go. All right, now I decided to see how much more pizza that is. So I divided the area of the big pizza by the area of the little pizza, the smaller one, and I got 4. 4. Okay, that means it's 4 to 1. 4 to 1 ratio. In other words, this pizza, compared to this, when you double the radius, you quadruple the area of the pizza. So, okay, so technically, since I'm getting 4 times as much pizza here, 4 times the area of this, and all I did was double the radius, since I'm getting 4 times as much pizza, this should be $40. And I'm only paying $22. So what is the better deal? This pizza! I would get that one and no doggy bags, okay? That's the key, no doggy bags. Well, that's something interesting. You know, you're going to be asked in the practice to kind of do that. What if you multiply the radius of something, a circle, times 2? Well, the area turns out to be quadrupled, 4 times the area. You double the radius, 4 times the area. Hey, what if you multiply the radius times 3? Well, what if we said here that this, instead of being a radius of 6, was 18, and the diameter is 36, but 18? You would have 9 times the pizza. If you multiply the radius of that pizza times 3, you end up with 9 times the pizza in what's left, not 3 times the pizza. That is pretty cool, and you'll see a pattern as you work on that. Hey, you're also going to be asked to do this. You're doing the even numbers today on 14 through 30, just the even numbers, 14, 16, 18, that kind of thing, on pages 534 and 535. You're going to be asked to find the total area to the nearest tenth of a figure, and there are a couple of them. So here's one of them actually, and it looks like kind of, you know, part of a basketball court or part of a court here. All right, so I see 2 figures here. One is a half circle up here, and one is a rectangle right here. So I'm going to get the area of the half circle first. So the radius of this half circle from here to here is not there. It's not marked. But you notice on the other side of this rectangle, we have one of the sides that's 4 feet. So that means this side is 4 feet too. It's a rectangle. So what's the radius? Half of 4 is 2. So the radius is 2. So I'm going to say area equals pi r squared. Area equals 3.14 times 2 squared. 3.14 times 4, because 2 times 2 is 4. And I get 12.56 square feet. Now that's the thing. That's for the whole circle. I only see half a circle that I need to find the area for, not the whole circle. So I divided 12.56. If this were a whole circle, I divided it by 2. And when I do that, I get 6.28. So the area of this right up here, not the whole circle, but that part, is 6.28 square feet. Now, it's easy to find the area of the rectangle. The formula is area equals length times width equals 5 times 4 equals 20 square feet. So what will I do with the area of this and the area of this half circle? Add them, right? I'm going to add them together. And when I do that, 20 plus 6.28, I find out is 26.28. Now, I'm told just to find the area to the nearest tenth. So 8 is in the hundredths place, 2 is to the left over here. And so I'm going to round that 2 up to a 3, and I get the 2 figures rounded area is 26.3 square feet. So again, that's one of the actual problems you're going to be working. You can watch this video over and over and over again if that's something that I went a little too fast on. Here's something else you're going to be asked to do. And yeah, if we bring that on down here, thank you, my trusty assistant. You know, you're going to be asked to do something that, well, a lot of times you can push a button on a computer and it does it for you. It's called make a circle graph. And this is really cool because you could just push a button on a computer and after you put in data and you can have it make a circle graph. But here's how you can do it on your own, all right? So first off, let's just say we got the data right here. Students in the school band. Remember what the school band is, right? And I'm sure now they're still practicing. Everybody's on Zoom and they're all playing their instruments while Miss Peterson directs, that kind of thing. Probably doesn't sound all that great, but we'll see. All right, students in the school band. Here's the grades, 6th, 7th, and 8th. The fraction of students that are in 6th is 7 out of the 20, all right? The fraction of students that are in 7th It's 2/5 of the group is in 7th, and in 8th, 1/4 of the group is in 8th grade. So what I have to realize is, well, every circle is 360 degrees, right? So I have a fraction of those students that are in 6th grade, 7/20ths of 360 will be how many degrees belong to the 6th grade. So I did this, 7/20ths of 360. I did a little simplifying before I multiplied. I got 126 degrees for 6th grade. 2/5 of these students in the school band are in 7th grade. So I said, well, let's take 2/5 of 360 degrees. Well, I got 2/5 of 360 total degrees, and the 7th grade owns 144 degrees of them, all right? And 1/4 of 360 for the 8th grade is 90. So 1/4 of 360 is 90. So 8th grade gets 90. Now just to test and see if I got this right, I'm gonna add these 126, 144, and 90 up, and yet I got 360. That would be the total circle. Now, the thing to do next is I'm gonna name my compass, right? In order to work this. And I drew a circle with a compass. Now when you use a compass, here's some things to remember, all right? This is a compass, and you need one at home, of course. Go get one right now if you don't have it right there. But you need a compass. Here's some hints. First off, make sure the top of the compass is tight. So this part right here, if it's loose, you gotta tighten it where it doesn't open on its own, right? I wanna be able to let it go and it doesn't open on its own. If your compass looks something like this, all right, you notice that it stays open wherever I put it. It doesn't just fall shut or open. And there's usually a screw here, right here, with some compasses that you can tighten the top, all right, tighten the top. Here's another hint. Secondly, make sure the pencil tip and the tip of the pointer part of the compass are about the same, all right? This should not be really low. This shouldn't be super high. They should be about the same so that when you touch them down, they both touch at the same time, all right? Don't push too hard when you do that. Third thing is, lean the compass. When you draw a circle, lean the compass. So watch, I'm gonna put the pencil, the tip here, the chalk is over here. As I draw my circle, I lean the compass towards the circle. So if I have it straight up like this, it's hard, it kind of skips, all right? But lean your compass towards the circle that you're drawing. Here's the last thing, twist the top of the compass. That's where you hold it. Do not do this. Oh, I'm gonna draw a circle, right? And then you end up opening and closing it, and it looks horrible. All right, so take only the top of the compass, lean it towards the place you're going, and draw your circle. All right, those 4 tips will help you use your compass. Of course, as you practice, you get that better at it. So I drew a circle, I have the center of the circle, and I'm gonna start with the easy one here, 90 degrees. So I draw a random right here. I'm gonna just draw a random radius. So I drew up from the center of the circle out to the edge. That's a random radius. Now, I could have drawn that anywhere, but now using my protractor, I'm gonna make a 90-degree angle. If you remember how we did this a couple weeks ago, I put the vertex on the vertex notch. This is pointing at the inside scale, 0. I wanna go up to 90, I put a mark here. So I counted on the inside scale up to 90. I lift up my straight edge. All right, there's a 90-degree angle right there. I just drew that. That belongs to who? Okay, that belongs to 8th grade. So this is going to be 8th. All right. Now, let's see. Let's do the 126-degree angle. And that is going to belong to 6th grade. So let's take this right here, what I just drew for the 90-degree angle. I put that on there, and I start at 0, and I'm going to count over to 126. And 126 takes me right about to here. All right, I lift and draw another radius. All right, that 126 belongs to 6th. And guess what's left? Well, that will be 144 degrees, I guarantee. I don't have to use this to measure it. Once I've done these 2 angles, I know whatever's left belongs to 7th grade. Now, the next step would be for you to color in with 3 different colors. You got it labeled, you got a title of it like that. Yes, you need to do something like that in the practice this today. And wow, so that's all part 2 of area of a circle, things that you need to know. Hey, tomorrow I got a special construction worker guest coming because we're going to do constructions. Make sure you have a compass. Make sure you have a straight edge. You do not need a protractor, but you need a compass and a straight edge. And so it could be a ruler. Thank you. See you tomorrow.